Yes, and we'll now talk about intrinsic clearance for the hepatic system. So in this case, we're talking about the intrinsic ability of the liver to metabolize drug. So we've already talked about liver blood flow and what could cause increases or decreases in liver blood flow. Now we're going to talk about what intrinsic clearance actually is. So let's dig into intrinsic clearance. Yippee-doo. Okay. Intrinsic clearance. As we talked about with clearance concepts, intrinsic clearance is the intrinsic ability for the organ to actually metabolize, or I'm sorry, to clear drug. It can take on values that are non-physiologic. They can be greater than blood flow. And that's when you have a shiny dairy. You have that really good intrinsic ability to clear drug in this case. Intrinsic clearance is also a clearance term, so it's going to be volume per time. Now, what are the determinants then of intrinsic clearance as we dig down, as we like to do, one step further? What are the determinants then of intrinsic clearance? Well, guess what, guys? It's Michaelis-Menten again. Isn't that exciting? So, the intrinsic clearance is going to be equal to Vmax, the capacity. In this case, it's going to be the number of liver enzymes all over the Km, which is the concentration where you reach 1/2 of Vmax, so where half of your enzymes are being occupied, plus concentration. So you can see here that this is just a rearrangement. The rate of metabolism divided by concentration, that gives you a clearance. So that gives you intrinsic clearance. So this is Vmax is analogous to is the capacity. Km is the affinity constant. We've been over this with volume. So as I think I told you at the beginning of the semester, if you understand Michaelis-Menten, you know, excuse me, a lot of stuff about kinetics, because we keep reapplying this idea over and over again. Good. So if we are asked, going back several steps, if we are asked if we want to make a dose rate change, we look at CSS average. Well, what determines CSS average? CSS average is determined by bioavailable dose rate over clearance. Well, we've talked about what determines bioavailability. We're now talking about what determines clearance. So what determines clearance? Well, it's Q times E. What's Q times E? Well, if it's for we'd have to separate out then the liver and other organs. If it's hepatically cleared, then it's going to be liver blood flow times the extraction ratio for the liver. The liver, we know, the E is equal to intrinsic clearance times fraction unbound all over Q plus intrinsic clearance times the fraction unbound. So one of the determinants of hepatic clearance is going to be the intrinsic clearance of the organ. Then you ask, well, what determines the intrinsic clearance? Well, here you go. It's going to be the capacity of the system, the maximal rate of metabolism given for a given metabolic pathway. So that's going to be the number of enzymes. I think of intrinsic clearance as equal to hepatic enzyme activity. So the maximum rate is going to be determined by the number of enzymes available. The Km is about the affinity. So it's the concentration of drug in the liver at which the rate of metabolism, the concentration at the rate of metabolism is half maximal. So it's the concentration where you're at half Vmax. It's the same thing as every other Michaelis-Menten. And obviously C is for the concentration of drug. Now, when the drug concentrations that we experience are much less than the Km, remember the Km is a concentration as well. These are both concentration terms, aren't they? This is the concentration where you're at half Vmax. So this is going to be in amount per liter per volume. So usually like maybe milligrams per liter or micrograms per milliliter. And also concentration of the drug. So if the concentration of the drug is much less than the Km, we know mathematically when there's a sum in the denominator, this falls out in importance, just like before. So our intrinsic clearance becomes really determined by Vmax and Km in most cases. But what has to be true is the Km has to be much greater than the concentrations that we see. Now, the total intrinsic clearance for a drug, the hepatic intrinsic clearance, I should say. So we're talking about, remember I told you hepatic intrinsic clearance is all about liver enzymes. So the total will equal the sum of the Vmax and Km for each enzyme system. So if a drug is metabolized by more than one enzyme, you're going to have to add up the Vmax over Km for, let's say, 3A4, CYP3A4, and maybe it's also metabolized by 2D6, and maybe it's also metabolized by 1A2. These are all CYP systems, right? So there will be a Vmax, which is the number of 3A4 enzymes, and an affinity for those 3A4 enzymes. There will be a number of 2D6 enzymes, and an affinity for those 2D6 enzymes, and on and on and on. So the total intrinsic clearance is going to be the sum total of each of the enzyme systems added together. What things will alter intrinsic clearance? Well, we've been actually talking about this already, haven't we? So when enzymes are induced, enzyme induction, that means that there's an increase in intrinsic clearance. So there's an increase in enzyme activity. This is usually due to an increase in the number of enzymes. So it's going to be an increase in Vmax. The number of enzymes are induced, are increased. The time course of this is going to take a long time because you have to make protein. Increasing, this takes a long time because you've got to actually make these enzymes. Enzyme inhibition, on the other hand, is really where we've got the love triangles, right? So two drugs maybe are competing for that same enzyme, competitive inhibition. So it looks like there's a change in the affinity. This is going to happen faster, isn't it? Because it's just a displacement issue with the enzyme itself. The other way you can have changes in enzyme activity in the liver is with liver disease. Obviously, if you have serious liver disease, the number of enzymes is going to be decreased due to tissue destruction. So you're going to see a decrease in your intrinsic clearance, aren't you? Oxidative pathways of hepatic metabolism appear to be more affected than conjunctive pathways. So that's going to be your CYP system and any of your type 1 metabolism routes. All right, so we've talked about, so far we've talked about our hepatic clearance, we've talked about liver blood flow changes, and we've talked about intrinsic clearance. In our next video, we'll talk about binding.